So we're going to continue our investigation in energy, and we're going to do so by looking at potential energy, which we are going to use a PE for. And potential energy is stored energy, and we have looked a little bit into potential energy and even kinetic energy back in our chemistry unit when we looked at heating and cooling curves. Potential energy is on your reference table. Here we go. Potential energy is M, which is our mass, times G, which is acceleration due to gravity, times H, which is height. The other way to write it would be Fg, which is the weight, times height. So mass times gravity is weight. All right, so this Fg right here is really just this Mg, mass times gravity. All right, so M is the mass, G is the gravity, and H is the height of the object. And this is going to depend on our position, the position of that object. The higher up an object is, the more potential energy it has, because that makes sense if you think about it, because it is dependent on height. So if height increases, so will potential energy. So let's do some examples. What is the potential energy of a ride if it has a mass of 420 kilograms and a height of 860 meters? So step one, I have to set up my triangle. I have three parts, so mass, gravity, height, because they're all being multiplied, so potential energy goes in my blank spot up top. So how am I going to find potential energy? Mass, which is 420, times gravity. And now if you'll remember, we've learned the acceleration due to gravity is 9.8 meters per second, also written as meters per second squared. So here's the deal, friends. If you are not provided a gravity, then you will instantly use the gravity here on Earth, 9.8 meters per second squared. And the height, it tells you, is 860. All right, so when we plug this into our calculator here, we get a real big number. We get 3539760 joules of energy. Woo, that is a lot of energy. All right, an object resting on the top of a hill has a mass of 18 kilograms and a potential energy of 310 joules. How tall is the hill? So we are looking for height. So we are going to do potential energy divided by mass times gravity. So my potential energy is 310 joules. My mass is 18 kilograms. And now we were not provided a gravity. So what did I tell you we do? We instantly use gravity on Earth, which is 9.8 meters per second squared. We're going to use this number so much, you're going to find it be memorized. You're not even going to need to use your reference tables to get this number. We're going to use it so much. All right. So 18 times 9.8 is 176.4. All right. And 310 divided by that value is going to give us a value of 1.76 meters. Our height is in meters. Okay, so how does potential energy compare to gravitational potential energy? This is where we have weight times height. Weight is the mass of an object times the gravity. That is what is weight. Okay, so when we step on a scale and we get our weight, That scale is taking into account your mass and the gravity here on Earth. Gravitational potential energy, we are going to write that as G for gravitational and then PE for potential energy. Objects raised above the ground have potential energy due to gravity. And again, the higher up we go, the more potential energy there is. So let's look at this example. Okay, or I'm sorry, let's look at this. It is going to depend on the height of the object. And it is going to depend on the mass of the object. Okay, so we have more height. There's more gravitational potential energy. If we have more mass, we also have more gravitational potential energy because the gravitational potential energy does depend on weight, which has taken into consideration mass of an object. So let's just do a quick example. The gravitational potential energy, which I'm going to abbreviate GPE, of a 15 kilogram object is 294 joules. What is the height of the object above the ground? So step one, we have to set up our triangle. All right. We have to set up our triangle. Gravitational potential energy is weight times height. All right, so we want to know how high. So we're going to do gravitational potential energy divided by weight. Now, weight is mass times gravity. So to find height, I'm going to do gravitational potential energy divided by mass times gravity, where my gravitational potential energy is 294 joules. My mass is 15 kilograms. Let me make that look better like a 15. And gravity is always 9.8 meters per second squared. So when I plug that baby into my calculator, I get a height of 2.0 meters.